And I mean, unless something amazing happens. Yeah, these are kind of long. I'd like to do a little review on Wednesday if I could. I'll have to finish up the second handout and then maybe a little bit review. All right, so we're talking about the arithmetic sequences. Whoop, gotta get scribbly here. Sequences in series homework handout. So the handout I gave, this will be due on, so I want to actually physically collect the answers from not just the answers. The answers are on the back, notice. All the answers are right here on the back, so I want you to be able to check as you go. But so I want to see the steps. We'll do about half of it right now. And then you fill in the other. So go ahead and get a piece of paper out, and you're going to give it, we're going to do about half the problems together right now. You do the extra ones that we don't do. Out of 20, we'll probably do 10. You do the other ones yourself and hand it to me for homework on Wednesday. So that's what will be due on Wednesday. Somewhere I'll put it up here. Homework due Wednesday is section, whatever it was, 3 point, what was it, 3.5? Yeah, 3.5. So Math Excel 3.5. And the arithmetic handouts. So we won't get the geometric one done, I don't think, till Wednesday. All right, so let's go through it. So they give you a couple formulas right up there at the top. These would be very helpful to put on your full sheet of notes for the final exam. A1 plus n minus 1d. And then I'll do the other one in a minute. All right, so let's start off. Question number 1. Find the 59th term of 5, 7, 9, 11, ... So you can tell what's happening in that sequence. That's a sequence of numbers. Got a definite pattern. Right? What's the next number in the pattern?
13.
13. It's just going up every time by how much? Just adding 2 every time, isn't it? So you could get all the way to the 59th term, couldn't you? It would just take a long time. It'd be easy to mess up. So that's why we're going to use the formula to make it easier for us to get all the way to the 59th term. So let's use the formula to do that. Now, the most important part of using that formula is to know what the n is, and the n is the 59. The n is always the ordinal number. Now, what's an ordinal number? It's a number that implies ordering. If I say 7, that's a normal number. If I say 7th, that's an ordinal because it implies order, doesn't it? When I say 7th, that means that's like what place they were in, right? They came in 7th place. If I just say 7, that could just be there were 7 of them, or I'm 7 years old, or who knows what. But 7th, that's an ordering, isn't it? That implies an order. So ordinal numbers, whenever you see that kind of a number like a 7th or a 3rd or a 5th or whatever, know right away that's my n. I'm just saying that to help you identify. That's always your n whenever you see the ordinal number. Right, Kara? Sure. What you got?
How do you know which one of these you have to use?
Yeah, well, for now, we'll use the a sub n. But I can tell you this right now. The s sub n is for sum. S stands for sum. When you're adding them, and that won't happen to the backside. See on the backside, starting number 13, they're all being added instead of just commas between them. That's when we'll use the s sub n formula. It stands for sum, adding them up. The whole front side, we'll use the a sub n formula. Okay, so ordinal numbers are always your n. So whenever you see an ordinal, 5th, 7th, 23rd, like that implies an ordering, that's your n. So n is 59. I'm going to use the formula they've got there. A sub n is a1 plus n minus 1d. So a sub 59 equals, I just put 59. That first n is a subscript, meaning it's lower down, like a submarine is lower down. Right, just a lower down, a sub 59 is a sub 1 plus n. What's n again? 59 minus 1 times d. Let me explain what these parts are. What do you think a sub 1 is? First term. A sub 1 stands for the first term, just like A sub 59 is the 59th term. So the subscript tells you the term number. It's like the address or something. So A1 means first term, and D stands for difference. Difference from term to term. So what's the difference from term to term in this list? 5 to 7 to 9 to 11. What's the jump amount? What's the difference from term to term? Well, that's the 2, isn't it? Yeah, the D is just the 2. It's the difference, the jump amount from term to term. So I'll put 2 in for D. And what was the A sub 1? What's the first term? 5. A1 is 5. You guys tracking with me? So A1 is 5. D is 2. So this is 58 times 2. 116. Whoop. 121. And hopefully that's the answer in the back. 121. Anything I can say to help with that? Just see how that all worked? So hope you're getting this down. You'll turn this back into me on Wednesday, right? We just did problem number 1. So write it down on something you can turn into me on Wednesday. Now I'll be giving you points for the work, that work. Now there's no points for just writing the answer 121 because you could just copy those from the back, right? So you got to show me. I mean, it doesn't have to be exactly like this, you know. Your work can be different, that's fine, but it's got to be some work. I don't think you could do all that in your head, so I got to see some work. Is that good on that? Everybody see what I did there? So again, A1 is first term, D is the difference from term to term. The N is the ordinal number, the 59. All right, shall we try number 2? So you got it on your paper there. Try number 2, and I'll finish it up in a second. Same formula, same deal. See if you can try it. Number 2. Oh, so what did we find, by the way? So 121, that's going to be the 59th term way down the line. That's what we basically found. 59th term way down the line. So number 2. Going up by 3 every time, isn't it? So that's the D, the difference, the jump amount from term to term. So AN is A1 plus N minus 1D.
It's A of subscript 46, right?
Yeah, good. So the 46, that's your N. Remember, the ordinal number is always your N. So that's your N. Put that in. A sub 46 is A1. What is A1 always?
The
First term,
so -1.
which is -1. N again is 46. D is 3. Which one is it? 135. Is it 134 then? 134. And look on the back. Yes, 134. We good? We happy about that? Want to jump? How about want to jump to number 4? And feel free to work ahead. Maybe get this whole thing done while I'm moving on through. I'm going to jump to number 4 because I know how you love fractions, right? You want to do that fraction one. So let's try number 4. I'm skipping number 3. Going to number 4. I would probably make those fractions into decimals. I think would be easier. Take 7 and divide it by 2 on your calculator. Or by hand, if you can do that. Make them decimals would be a little easier, I think.
Can't you just take 7 halves and subtract 3 and see what the difference is between them?
You could do that.
Okay.
What's the difference?
1/2.
Yes, it is.
It's not that I didn't understand, like, the dot thing, it's just like, I got really confused. Because the last 2 were really hard.
Yeah, they are.
I'm salty about that. I'm super salty about that.
They are tough problems. I'm glad you're working on them because many don't even try them.
Well, math is not optional for me.
That's right. You're going up the line in math, so you need to be learning that stuff. Yeah, that's good. All right, so I would just divide these on my calculator. 7 divided by 2 is 3.5. 9 divided by 2 is 4.5. Then it's really easy to see what the difference is, what the jump amount is from term to term. What's happening from term to term? Just going up by 0.5 or 1/2 is fine if you want to do as a fraction. I'm just going to go with decimals. Same thing. It's going up by 0.5 from term to term. All right, use the formula. Find that 52nd term. Check the back of the paper when you got it. So plug 52 is my n. A1, the first term is 3. N is 52. D is 0.5. And so it's 3 plus 51 times 0.5. Use your calculators at 25.5 plus 3, 28.5. There we go. There's probably 2. Let me think. I'm rethinking my thing. I bet there's 2 arithmetic and 2 geometric. These handouts are longer. 4, 5, 6, 39, and 9 through. Yeah, that'd be like 44 questions. That's probably close to what it is. All right. Anyway, we good there? I don't exactly remember. I'm sort of guessing. All right. Let's go on to number 5. Number 5 says A1 is 8, D is 3, and it says it wants 2 things from us. It says find the nth term formula. Let's do that first, and then we'll do the second thing, which is the 39th term. So let's first find the nth term formula. So how do we find the nth term formula? Well, we start with the same old formula we've been using. AN is A1 plus N minus 1D. There we go. Put in the 8, put in the 3.
So it would be 8 to the 39 is our first.
Nope, just nothing else. No, don't worry about 39. Put the 39 aside. We're not even going to mess with that. We'll get to that later. All we're doing right now is I just took the general formula we've been using and I put in the A1 is 8 and the D is 3 that they gave me. And then just go ahead and distribute. You can distribute from the right side just like you would from the left. It's not different at all. Eight minus 3 is 5 plus 3n.
Does it matter if you switch them, like 3n plus 5?
Oh, no, that's okay.
They're like terms.
Okay, we good so far? Now, so that's the first thing they want. They want the nth term formula. There it is, 5 plus 3n or 3n plus 5, either way. That's, if you look in the back, that's the first answer they want for number 5 is the 5 plus 3n. So we're done with the first part. Now the second question they asked is they said, find the 39th. Getting kind of scribbly there. The 39th term. What do you think I should do? Yeah, what do you think the 39th is? That's it, because it's the ordinal. Remember, the ordinal numbers are always your n. Anything that implies an ordering, 39th. So that's it. Just take that formula we just found, 5 plus 3n, and put 39 in for n. 90 and 27, 117 and 5, is it 122? Put the other answer in the back, yep. And there we go. We good? Want to jump down and try a hard one like number 7? It's got negatives and fractions and everything. How about we do number 7 next? And I would make that fraction probably into a decimal. You don't have to. Might be easier. Try number 7. Maybe you have time to do number 6, 7, and 8 as we're going through this. Getting your homework all the way done.
You could leave them as decimals, right?
Yeah, totally. Yeah, so I'm just going to convert that d minus a half to d minus 0.5 on number 7. So plug in your A1 and your D. And distribute. So 28 minus 0.5 is 27.5 plus 0.5 in. Yeah.
Wouldn't that be a negative 0.5 that you put down there, or no?
I'm confused. I did put a negative 0.5 here. Is that what you mean?
No, because it's a negative 0.5 up there.
Oh, you're right. I'm totally messing up, huh?
Positive 0.5.
Thanks. Somebody's finally helping me. Thank you. Yeah, I messed up. You're totally right. Let's go back and fix that. Yes. Minus 0.5 in and then plus 0.5, huh? So it'll be 28.5 minus 0.5. Yeah, I'm getting it all wrong. 28.5 minus 0.5 in. There we go. Hopefully that's what the back says. Yeah. Or they wrote a half, but same thing. Good. Thank you. And there's the first answer. But now for the second part, they want the 39th term. Now, just plug in 39 for n. 39th term. So 28.5 minus 0.5 n. Plug in 39. What is that? 19.5?
It's 20 minus 19. Yeah,
And,
39 minus 1 is 38 times negative 0.5.
And that'll be 9.
Yeah, minus 19. Yep. Minus 19.5.
Mm-hmm. Is there confusion? There we go. Is that good? Renee, what's confusing you?
I don't know how did I come out like 0.5 less than each?
Okay, right here you have 28.5 and then you suddenly change it to 28. That's one mistake. See that?
But up here, that's just 28.
Right, but then you combine the 28 with the 0.5 at the back. Oh no, that needs to multiply, yeah. 28 and the 0.5 in the front, I mean, to be 28.5. Oh, you plugged into a previous version. Yeah, you just plugged into this one rather than the final simplified one. That's fine. You just plugged into the unsimplified one. Is that making sense?
It would still come out the same?
Yeah, these are just three equivalent forms. This is just cleaner.
Okay.
Yeah, so it still works. We good? All is well? All right, let's move on. Number 9. So number 9, things are getting a little more complex here on this section 9, 10, 11, and 12. So let's see, on number 9 it says the 10th term is 43 and the 51st term is 166. Okay, you guys ready? Things are getting a little complex here. We're going to use the same formula, which is a sub n is a1 plus n minus 1d. Write it twice, once for each of these. So far, so good? Okay, so now let's plug in stuff that we can plug in. The 10th. What is the 10?
A-N?
That's n. It's just n.
Yeah.
So it's in, right? Remember the ordinal number, 10th, 10 is in. So plug that in for in. So that means a sub 10 is a1 plus in 10 minus 1 times d. And then the 51st, the 51, that's also in. So a sub 51 is a1 plus n minus 1, n is 51 minus 1d. So far, so good. I really encourage you to write it just like I'm writing it. Side by side, because it's going to get kind of messy. It'll be nice to have it just so. Keep it kind of organized. So everybody good so far? All I've done so far is plug in the n. Okay, now it says up here that the 10th term is 43. 10th term. So that means a sub 10. Well, what does a sub 10 stand for? 10th term. Like a sub 1 stands for first term, right? The subscript is the term number, right? It's the address. So a sub 10 means 10th term, and they're telling me 10th term is 43. So put 43 there. And 10 minus 1 is 9. Good so far? 10th term. So the whole thing, if I write a sub 3, for example, what does that mean? We got to speak their language a little bit more. Let's get their language going. What does a sub 3 mean? Third term. If I write a sub 12, what does that mean? 12th term, meaning if you list out the terms, the 12th one down the line. It's like an address. You guys making sense? There's some sequence here which we don't know yet. We're basically trying to find out what the list of numbers is that they're thinking of. It's like playing a game. I'm thinking of a list of numbers. The 10th number in my list is 43. The 51st number in my list is 166. Find my list of numbers. That's basically what we're doing. Is that making sense? There's some list back there. Maybe I don't know what the list is, but maybe it starts with a 6, and then it goes up by 3 every time. I have no idea yet. I'm just guessing, you know. There's some list, and if I say a sub 3, I mean the 12th, the third term in the list. If I say a sub 12, I mean whatever the 12th term in the list is. I don't even see it there yet. Are you speaking? I'm just trying to get you fluent in the language here. Is that making sense? How they talk, what their symbols mean. Is that good? So a sub 3 means the third term in the list. A sub 12 means the 12th term in the list. So right here, a sub 1 means the first term in the list. That'd be, that's a sub 1, huh? 6. If that was really the list, that's not even the list, but if it was. And so when they say a sub 10 here, we need to speak their language to know that's, 10th term. And the 10th term, they told me explicitly, is 43. So I put a 43 there. The 10th term is 43. Is that making sense? And the 51st term is 166, they say right here. And 51 minus 1 is 50. So we okay to there? So we're playing the game backwards. I'm thinking of a list of numbers. The 10th number in my list is the number 43, and the 51st number is 166. So now I want to find their list of numbers. So what am I going to do? I've got two equations with two letters. Instead of x and y, it's a1 and d. Same game. Two equations, two letters. So bring this one over here. 43 is a1 plus 9d. Line them up vertically, and we make opposites like we were just doing, huh?
Oh, God.
Remember that? And so we have two equations with two. It's just like having two equations with x and y. Now, these are going to be super easy to handle, and they're going to be the same every time, which is very nice. What would be the easiest to make opposites? Those a1s. Just make the bottom one negative. Does that make sense? So multiply the bottom equation by just run a negative sign through the bottom equation. Everybody see what I did there? negative 43, negative A1, negative D. I just multiplied the bottom equation by negative 1. I just took this equation and went negative 1, negative 1, negative 1. On that bottom equation, now add them up. 166 minus 43, what is that? 123. A1 minus A1 is gone. 50D minus 9D. 41D. Let me let you catch up. Is this making sense what I'm doing there? We good? So you just make the bottom equation negative so that the A1s are opposites. A1 minus A1 drops out. Last step to finish solving for D. Divide by the 41. Isn't that 3? So I got D. And now you go plug it in. Right? You guys are pros at this whole process, right? 2 equations, 2 letters. Right? So plug it in wherever you want. Remember, it just really doesn't matter. So I'll just grab this one, let's say. Bring it down here. So 43 is A1 plus 9D. And my D is 3. So put in 3 there. So 43 is A1 plus 9 times 3. Plug in the 3 for the D. 43 is A1 plus 27. Subtract 27. A1 is 16. All right. We're almost done now. We're very, very close. We basically got it. We just got to put it together now. So A1 is 16, D is 3. Does everybody see what we've done so far? So we just took the original information. They're playing a game, right? I'm thinking of a sequence. Its 10th term is 43. Its 51st term is 166. So I wrote the formula down for both cases, plugged in the n, and then got the 2 equations, made the A1s opposites so I could find D, find A1. Now, we got A1, we got D. I'll bring it over here. A1 is 16. D is, was it 3? Yeah, 3. Okay, now remember the equation is the same formula we've been using all along. AN is A1 plus N minus 1D, same formula. Now you plug in your A1, you plug in your D, and you just gather like terms. Now that you have your A1 and your D, distribute. 16 minus 3 is 13. Plus 3n. Hopefully that's the answer. Yes. We're done with number 9. Oops. Is that making sense, what we did there? Questions? All right, you want to try one of these? Like number 10? So give number 10 a try. Same process. So number 10. So the n is the 7th, the 7. And the 7th term is 23. All good to there? Getting those two equations? And then put one underneath the other and multiply one of them by -1. Doesn't really matter which one, just multiply one of the equations by -1 and get the A1s to drop out. Same thing every time. So multiply through the bottom equation by -1. Add them up. T is 4. Are we good? Got D, and so then plug it in. Subtract 24. A1 is negative 1. Did y'all get that? A1 is negative 1. D is 4. Then I'm going to go on and finish it up. So A sub n is A1 plus n minus 1D is A1, negative 1. Boom, boom. And there we go. Negative 5 plus 4n. Is that the answer in the back? For number 10? Yes, it is. All right, I think I'm going to skip 11 and 12. Because they are the same. Maybe you've already got one or two of them done. Questions I can answer? Okay, good. Everybody seen how this process works? No questions? All right, on to the backside. And number 13. Something's suddenly changing on the backside. Look at that. They're being added up now. Does everybody see? They're being added now, and they were not added. Look at back at number 1. Problem number 1, they just had commas between them. Does everybody see that? But on problem number 13, they suddenly have plus signs between them. They're being added. So guess what formula we're going to use now? Since they're being added, we're going to use the S sub n. S stands for sum. Bless you.
Thank you.
S stands for sum. When they're being added, you use the S sub n formula instead of the A sub n formula. See how they're being added up, and they want us to find the total of what they all add up to equal. Okay, so this is going to be a little tricky. Are you ready? So let's go through what the different parts mean. What does the n always mean? It's ordinal number, right? It's the number of terms. A1, what does A1 always mean? First term. A sub n is a way of saying the last term. Because there's n terms, so A sub n, the nth term, is the last term. Did that make any sense?
No.
If there's 10 total terms, then A sub 10 is the last term. If there's 37 total terms, then A sub 37 is the last term. If there's n total terms, then A sub n is the last term. Right? Well, just use it for now. It'll probably sink in more as we go. So n is the number of terms, A sub 1 is the first term, and A sub n is the last term. So I've just got to plug into that formula the number of terms in this list, and then the first term and the last term. Hey, I've got the, let me just leave the n part in the front for a minute. But we know the first term and the last term, don't we? What's the first term in that list? 7. What's the last term in that list? 103. Right? That good so far? So we've got the first term. We've got the last term. That part's easy. Now the hard part is the number of terms. How are we doing? Am I making any sense? Am I starting to do, you guys getting tired? Am I starting to do the Charlie Brown teacher, the wah, wah, wah? Am I coming across? I'm feeling it myself a little bit. I'm trying to get rid of this cold, so I'm feeling a little spacey too. So maybe you're feeling spacey. Let's dial in here for a few more minutes. Get these last few down. So n over 2. I'm looking at this list, 7, 9, 11, dot, 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 all the way to 103. That's a lot of numbers. We're trying to add up all those numbers, right? You're getting the big picture here. We're trying to go, what is 7 plus 9? I don't know, what is that, 16? Add 11, I don't know, whatever that is. Keep adding, da, 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 go all the way to 103. Add them all up. What's the total you get? It's a big question. You know, it's a big number, I'm sure, whatever it is. What's going on from term to term? What's going on here from term to term? It's going up by 2 every time. That's the difference, the D, the jump amount, right? It's going up by 2, term to term, right? And they're going all the way to 103. That's a lot of terms. How many terms? I mean, the dot, 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 that means there's a bunch of them missing. How many terms are there really if we saw them all? I don't know, but that's what I need to figure out here. That's what n is, remember? Number of terms. How in the world am I going to figure? I know the first term is a 7 and the last one's 103, but how am I going to figure out the number of terms? I'm going to use the other formula, the one we've just been using for the last, 40 minutes. So use the other you're going to actually need to use both formulas on this problem. So to find n, you go over here and you use a sub n is a1 plus n minus 1d. Use the other formula to find n. So use this formula to find n. Once you get your hands on n, bring it back, pop it in right up here, and finish up the problem. Make sense? Double formula usage. Here we go. A1. What does A1 stand for? It is 7. It always stands for the first term, right? A1's the first term. So that's a 7. Very good. And, I don't know, that's what I'm looking for. What's D? The difference from term to term, 2, right? The jump amount from 7 to 9 is an add 2. From 9 to 11 is an add 2. That's 2. What's A sub n?
That's what we don't know. How many terms?
Back over here. A sub n. What ended up in that spot? Right? It's the last term. A sub n means last term, doesn't it? You forget so fast. I know how it's hard when you have a new math concept. So 103. Is that making sense? Good so far? So A sub n means last term. 103. A sub 1 means first term. D is 2. See how I have an equation I can solve for n there?
No.
So solve that for n. When you get n, bring it back and plug it into the other equation. Distribute that. 7 minus 2 is 5.
What is 7 minus 5? 2.
I distributed that 2 through the parentheses.
Yeah. Okay.
And now finish solving for the n. Subtract 5 from both sides. Said 98 is 2n. Last step, divide by 2. 49. That means there's 49 total terms there. You know, we're just seeing dot, 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 so there's a whole bunch of them missing. But there's 49 total terms there. I'm only one step from the answer now. What do I do with that n? Grab that n and bring it all the way back over here. 49 over 2, add these other, this is 110. You can use your calculator, just take 49 divided by 2 times 110, and you can let me know what the answer is. Well, I bet it's whatever the back says here. 13, is it 2695? I'm hoping. Good. Because that's what the paper says it's supposed to be. So that means all those numbers, 7 plus 9 plus 11, added up all the way to 103, adds up to 2,695. Any questions I can answer on what just happened there? Yeah?
Who figured this out?
Yeah, that is such a great question because I want to tell you. Let's do one more and then I'll show you. Gauss, Carl Friedrich Gauss, as a youngin', 4th grader. Yeah, I'll show you. It's a great story. I want to tell you. Glad you asked. Well, let's do one more until we're comfortable, and then I'll show you how, and you'll be able to come up with it.
Right here.
Yeah, he's one of probably the greatest mathematician ever. But so yeah, he was doing things in high school that I'll never do. Yeah, yeah. He really was. He was like 3rd or 4th grade. Yeah,
4th grade prodigy.
he was a prodigy. Yep. All right, so we good with that? Is that making sense? What happened? So the S sub n formula. It's a tricky way to add up all the numbers 7, 9, 11, all the way to 103. There's the formula. So the main thing to know is what the players in the game are. N is the number of terms. A1's first term, AN's last term. We know the first term and the last term right away. What we had to work hard for was the number of terms, right? To get that, we went over and used the other formula. Got the number of terms, brought it back, then finished up. All right, let's try that on number 14.
What's the real world application of this?
Oh, all kinds. 64, 67, 70, plus 640. Imagine that by hand? Look at that. I mean, even with a calculator. Imagine trying to add that up by hand? You'd surely mess up. I would. No way I would do that perfect.
Why would anybody even care?
So here, let me give you one real life application. You know, like if you have some kind of stadium seating, it goes up like a pyramid. It's like you have I will say 20 seats in the first row, and then there's like 22, it gets a little wider, 24, 26, 28. You want to add all those up. You don't want to do it by hand.
Can't
It's
do
a
it
series.
with a calculator?
Oh, you could. But what is the stadium? It starts at 20, and it's 22, 24,
Like Fresno
26.
State.
Yeah, and it gets wider and wider. You got like 50. You want to add all the
Computer
time.
algorithm.
You know who writes those computer programs?
Computer
People that
programs.
understand this.
Yeah, that's not me.
It could be you. You make big dollars. It's a
I
fun
hate
job.
computers. I hate them.
Yeah, I think they hate me
I'm going
usually.
into natural science, not computer science.
Okay. All right, S sub n. How do we know we use the S sub n formula instead of the other one? How are you going to know which? How are you going to remember? What is it?
You see the dots.
Sum. S for sum.
You see the dots.
You do what?
You see the dots.
No, it won't always be dots. Sorry. See, it's 17 through 20. There's no dots there. So yeah, no, the sum. It's S. It stands for sum when they're added up. So when you see the plus side, you go, oh yeah, S sub n.
I don't know.
So remember, n is number of terms. A1 is the first term, A sub n is the last term.
We're going to have to do the other one too, so you might as well write the other equation.
Yeah, use it in time.
Yeah, but it's still going to be up there.
All right, so let's plug in what we know. We know the first term, 64, no mystery there. Last term, 640, no mystery there either. The mystery's in the n. So we go use the other formula to get our hands on n.
So A then is 640 equals.
Good, yeah, A sub n is last term. A1 again is first term.
Oh, that's numbered. First term is 64.
Check the back. Is it there?
Oh, so it's there. I got the N.
What's the difference from term to term?
3.
Very good. It's going up by 3 every time. One, 40, 21, 5, 79. Is that right?
Yeah.
3 and divided by 3. Is that what it is? Thank you. 193. So get that in and then bring that on back and pop it in there. That's what I thought. 704 is what that is? And then, yeah, then that's as far as I can go by hand. Let's see. 60, bless you. 67,936, I assume. Wouldn't want to do that by hand. Even with a calculator.
67,936.
Is that coming out okay for y'all?
Okay, so this is the sum of the series.
That's the sum of the series. That's what they all add up to. If you add up the numbers from 64, 67, 70, etc., just going up by 3 every time, all the way to 640, they'll total 67,936.
Okay.
That's what they'll total. You good? All right. Look, I think we should jump ahead to number 16 because those got little fractions there. Just make sure that's okay for you. You okay with 15? 15, the difference is just negative 5, negative 5 every time. That's the only issue on that one. I think that's probably okay for you. Well, I'm skipping a couple here, aren't I? So there we go. Try that one. You want to add all those from 3, going up by a 4th. I would totally use what? Not fractions, but decimals. I think are a lot easier to work with. So I would use decimals in my calculator. So I'd make this 3 and 1/4, a quarter.
3 and 25.
Yeah, 25 cents, huh? $3.50, that's 3.5, and 3/4 is 75 cents. And yeah, I would just make those all into decimals. Use my calculator, just, do it that way.
I didn't need this. I don't need these numbers. So 10 over 2 times
We good, so that's a bit.
So the last one in the series is 25. First one is series 30.
You're doing your homework right now, right? You're getting it more than halfway done? Maybe you're filling them, maybe you're fast enough to get them all done as we're going.
No.
I bet some are.
At least I can go back and watch the YouTube, and it's going to be helpful to me.
Maybe I'll play a prank and just put back a big YouTube from my office that just says dot
Would
dot
this even
dot
bother
Renee.
I'll go to the dean.
She'll think
Would
it's
this
funny.
even be on? I know. Since
What's
you
that?
weren't here, you didn't get this. Would it even be on YouTube? Because if you didn't come to class, you didn't get this. So where would you really?
Yeah, I think I'll put it up as a link. I think it might already be there. I'll check.
Last
That's a
year?
good question.
Last year, my geology teacher rickrolled us for our final review. On the final review file, we pulled it up, and it was that video with the guy singing, "Never gonna give you up." They call it getting rickrolled, and we all.
I never heard of that term. Okay, that's what was there, huh?
It was a big thing last year.
What a goofball.
So we didn't get a final review.
So number of terms, first term, last term. Okay, so don't know the number of terms. First term is 3. Last term is 25. And, all right, what are the number of terms? Got to go over and use the a sub n is a1 plus n minus 1d. A sub n again is last term. A sub 1, oh, I wrote the wrong thing there. A sub n is last term. A1 is first term. So last term is 25. First term is 3.
Oh, wait, no.
Yeah, and the difference is 0.25, huh? We good? How are we doing? Are we still having fun?
No,
Were we ever having fun?
not today.
I'm having fun. I get paid to do this even.
And you've been doing it for like 20 years.
It's a happy job. It's true. All right, multiply through by that 0.25. Good there.
-1 times
You're not really going to go 1 times 0.25 in your calculator, are you?
My brain is mush. I was up till like 1 o'clock in the morning doing homework last night.
$3 take away a quarter.
2.75.
$2.75 leaves you $2.75. Good. Now subtract $2.75 from both sides. And $25 take away $2.75. $22.25. Whenever it's number monies, we can, or money numbers, we can do it a little bit better than normal, huh? So 0.25 in. Good there. So what's that? 89? So n is 89. We good? And then plug that in. So take that and put it in. 89 over 2, what's that? 28. And the answer is 1,246, says the bottom of the page. Is that right?
Well, it's got to be right, it's the answer.
Well, sometimes answers are wrong. But this has been refined over several years of, it had many mistakes in the beginning, but now it's right.
So I totally.
Sometimes my Excel is wrong too.
Not very often.
I've had like 4 or 5 times.
I've never had
I'm a
that
doubter,
Excel
Abraham, to
before.
tell you the truth. I've did it for 8 years. I've had a lot of students come to me, and I think once there was a legit mistake. But
I think it's mostly human error.
we good there? 1,246? All right. Let's do. Okay, let's talk about. Okay, we got 20 minutes left. We got to finish 17, 18, 19, 20. Let's talk about where did this come from? The great question was asked. Who discovered this? As I told you, Carl Friedrich Gauss. It's a famous story from math history. Carl Friedrich Gauss, a young Gauss, probably the greatest mathematician ever, either him or Newton or It's debated. Anyway, Archimedes. So Gauss, in my opinion, probably the best. Carl Friedrich Gauss, he was in 4th grade. So the story goes, well, his history, he was like 4 or 5 years old, and he was correcting mistakes in his dad's bricklaying books. His dad, it was the 1800s. Gauss grew up in Germany in the 1800s. And he, like I said, he was 4 years old, 5 years old, something like that. It's reported that he was correcting, his dad had a bricklaying business, and he kept the books, in the house about adding up things. And Gauss would correct some adding mistakes in his dad's books, 4 years old, 5 years old. And then he went on to many great things and did what we're about to show in 4th grade. From there, he went on to, the village recognized his genius. His dad wanted him to take over the bricklaying business. But he was in a small village in Germany. The village recognized Gauss's genius, and they pulled together a bunch of money to send him off to the university. And when Carl Friedrich Gauss got to the university, like 15 years old or something, he would take classes like this or calculus or whatever, and he would, calculus it was discovered around that time. But he would quickly run ahead of his professors. That'd be like if there's somebody in there and they were helping me out and and finding new and more advanced things. He was doing that. All of his classes just quickly went ahead. Like as soon as he finished, he became one of the professors there at, I don't know, some super young age, and went on to discover things so fast. Carl Friedrich Gauss discovered new math and science. Like back then, the math, science, philosophy people, they did it all. They weren't so specialized. Like Carl Friedrich Gauss did science, astronomy, figured out stuff about the planets and the rotations and all that. Math, of course, philosophy. Well, I don't know, maybe Gauss didn't do philosophy. Number theory was his big specialty. Anyway, did many, many great things. Now we're so specialized, right? We have doctors that just study the left pinky finger. They get really, really specific. There's more knowledge to be had. So anyway, Carl Friedrich, here's what he did. 4th grade goes the story like this. The teacher was upset with the class. And the teacher said, all right, take out your slates. The 1800s had these little slates, little small chalkboard things, right? And said, I want you to add up the numbers 1 to 100. All the numbers 1 to 100 on your slates. I think the teacher was just trying to buy time, be my guess, right? I mean, what a waste of time. You imagine how painful this would be with a slate? Like 1 plus 2 is 3. Then you got to add another 3. 1, 2, and now it's 6, right? I added 1 and 2, 3. Add 3, it's 6. That's 1, 2, and 3 added up. Now add 4, it's 10. Now add 5, it's 15. You got to erase the slate every time. Now add 6, it's 21. Now add 7, it's 28. Now add 8, right? Keep going all the way to 100. Keep erasing the slate every time you add 2 numbers up, right? All the way to 100. He had the class want to do that. Add up the numbers 1 to 100 all the way with their slate. Well, Carl Friedrich Gauss thought, well, why don't I just try something creative? Einstein's old saying, for a scientist, imagination is more important than knowledge. I don't know if you ever heard that. And what he means is sometimes scientists just try stuff. They just use their imagination and give something a shot, and it works out sometimes. Imagination is more important than knowledge sometimes. So Carl Friedrich thought, I don't want to add up all those numbers on my slate. What if I just reverse the list down below? What if I just write the list backwards? Let me just see what will happen. I'm just going to write it backwards, like this. And then add them up. What will happen if I just write them backwards and then just add them up that way? What will that do? Well, just add them straight up and down, like we do like terms and stuff. Be 101, right? 1 plus 100, 101. Okay. 2 plus 99?
101.
99, 100, 101.
101.
98 and 3?
101.
Yeah, 101 again.
Oh, shoot.
Okay, so yeah, and this one, 101.
It's all 101.
101. 100. Okay, yeah, that's cute and everything. So what? No. That's far more than cute and far more than so what. That's it. What do I mean that's it? Do you see it?
That's the thing.
We can do this thing like that now. What? You also got to make the connection. How many 101s do we have there?
50.
I've got 1 in this slot. I've got 101 in that slot. I've got 101 in that slot. The first slot, the second slot, the third slot, all the way down, to the 98th slot, the 99th slot, and the 100th slot, right? How many 101s do I have there?
100.
I got 100 of them, don't I? I got one below each number, don't I? I got 101s. They all came out the same. How do you add up do I have to go 101 plus 101 plus 101 plus 101? How do you add 100 101s quickly? And you multiply, don't you? We all know that, right? That's how you add 101 100 times quickly. But that's the list twice, because we did it forwards and backwards, right? That's twice as much as we need, right? That's the list forwards and backwards, isn't it? So whatever this answer comes out to be, it's going to be twice as much as we need. It's the list forward and backwards. We just want the list once. So what do we got to do to this answer to make it right? It's twice as much as we need right now. So what do I do to it? Divide by 2, right? Cut it in half. And do you see this right here? See what this is? Remember our formula? N over 2 times A1 plus AN. Do you see what we just did there? He took the first number in the list, A1. He took the last number in the list, AN. Added them together, 1 and 100. First number, last number. N is what? The number of numbers, 100 numbers, divided by 2. That's the formula, you see. You can work this out. This is 50, right? 100 over 2 is 50, right? Times 101. 50 times, how do you take 50 times 101? How do you do that? How do you multiply 5 times 101? Well, it's going to be 505, right? Then just throw a 0 on the end. 50, 50. There it is. There's the numbers 1 to 100 added up. The story goes like this. Carl Frederick brought up to the teacher within minutes. Remember, the teacher was trying to buy time. Let's get those kids busy and out of my hair with their little slates, right? Carl Frederick came up in minutes with the answer 50-50, the correct answer. So numbers 1 to 100. And the teacher assumed he was cheating, and therefore sent him to the back of the room as discipline. I don't know if that's all true, but that's the way the story has come down over time. Carl Frederick got it because teacher couldn't believe he'd come up with it that fast. 50-50, and the rest is history. Carl Frederick went on to be the greatest ever.
Yeah.
Maybe
so
maybe the instructor was
On the
jealous.
17th. What do these giant E things mean?
Yeah, no, we got to go there. All right, so 50-50. So there's how they came up with that formula. Do you notice something about math for 1 second? Math is patterns, isn't it? Carl Frederick noticed a pattern. Math skill is pattern skill. That's what it is. That's what math ability is. It's the ability to recognize, use, describe, predict patterns. That's math. Math is patterns. That's all it is. And Carl Frederick had an eye for a pattern, and he could pick one out and describe a formula, write a formula that would predict the pattern. All right, let's do those last 4 questions. Number 17. What is that big squiggly thing? Is it a Greek letter? Anybody know? Is it a Greek letter? Yeah, that's exactly what it is. Yeah, it looks like a fraternity sign. Which Greek letter is it? Doesn't it look like an S? Sort of. It's an S. It's sigma is how they say S in the Greek alphabet. It's the capital sigma. So it's an S. So you don't need to speak Greek, and who cares about all that? But just know it's an S, because that'll help you. Guess which, it's an S, it's a Greek S. So guess which formula I'm going to use if that's a Greek S?
the sum.
The S formula. Yeah, it stands for sum. That big symbol stands for the sum of this formula as you plug in 1 all the way to 40. In other words, they want you to take the formula 3 plus 2 in, and they want you to plug in 1 first. What do you get if you plug in 1? 3 plus 2 times 1. 3 plus 2, 5. And then they want you to take the formula a second time, but this time plug in 2. So this is n equals 1, n equals 2, and you get 3 plus 4, 7, huh? And then they want you to take the formula 3 plus 2 in again. You just keep using the same formula. Now plug in 3. Going to get whatever that is. 3 plus 2 times 3. 3 plus 6, 9. dot, 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 all the way. What's the last number we're supposed to plug in? 40. Yeah, you start at the number on the bottom. You end at the number on the top. So they want you to go from 1 to 40, plugging into that formula every time. 3 plus 2 in. 3 plus 2 times 40. 3 plus 80, 83.
Okay.
And then, hold on, and then add those up. That's what the big Greek S is. It means sum up. So it means take that formula 3 plus 2 in, plug in n equals 1, n equals 2, n equals 3, n equals 4, n equals 5, n equals 6, all the way to 40. All the way to 40. Get the numbers and then sigma them, sum them, the big Greek S, add them all up. So this is really the question they're asking me.
We literally have to sit there and
We have to do it all.
Oh, no.
We can use the formula, can't we?
Oh, yeah, yeah.
Okay, I was gonna say, because we know the first letter in the series.
Yeah, oh, no, we're good. We're good. I'm just making sure you understand.
We know how many.
Let me go. You're totally right.
Okay.
We're going to do exactly that. So, but I just want to make sure you understand the feel of what that's saying, in case they throw you a curveball and try to trick you. Know what that symbolism means, a big Greek S. So yes, sure enough, we're not going to do this by hand. No way. We're going to now use the S sub n formula from Carl Friedrich Gauss, our favorite mathematician. Maybe. A1 plus AN. You know, I'm actually, though, I'm hoping I'm really your favorite mathematician.
Yeah.
And I'm actually a lot more famous in Germany than Carl Friedrich Gauss. My name, have I already done this before? I do this, I just goof around. My name is in more places in Germany than anyone. Tied with one other. Tied. Heron. 8, it's just my spelling too. I am famous over there. I'm all over the place. It means men. I'm on all the men's bathrooms. I had a professor, Cal Poly, start of fall. He was doing roll the first day, and he stopped to get to my Heron. He went, Heron? I went, yeah, here. He went, I was traveling in Europe this summer, and in Germany, you know, your name is on all the bathrooms. I'm like, yeah, I heard that. Thanks. All right, so n over 2 times a1 plus an. So what is n? Number of terms?
40.
Yeah. This time we don't have to work so hard. These are going to actually be easier than those last 4 were. Because, yeah, we know how many terms, huh? This right up here is the number of terms. There's 40 terms. So this is going to be easier. We don't have to work so hard. We don't have to use the other formula. A1, remember that always means first term. What's the first term? That's the 5, huh? First term is 5. And what's A sub n always? Last term.
Which is
The 83. There we go. That making sense? So that n is the number of terms. A1 is first term. An is last term. So really, I didn't need to find the 7 and the 9 and all that, did I? All I really needed to do was get the first term and the last term, huh? So we get 20 times, what's that, 88. So calculator, what does it say? 1760. There we go. 1760. Let's try one of these, and then we'll be done. We'll do our free clicker, and we're out of here. Is everybody good to that one? You want to try? Which one looks hardest? How about number 19? They got some fractions there. Why don't we do number 19, and we'll have done more than half your homework. We didn't even get to the other handout, the geometric.
good.
So we'll do that next time and do a little final review. So try 19. Same formula. All you need is first term and last term, really. I'm going to change that fraction to decimal right away, just easier. Okay, so yeah, I just need the first term, which which should be what, 7.5? And then the last term is 60, 8 minus, whatever comes out when you put in 60. Minus 22. First term is 7.5, last term is minus 22. Is that good? And now plug into the S sub n formula. And how are you going to remember that you're supposed to use the S sub n formula, not the A sub n? Yeah, because it's S, huh? That's a Greek S. I guess it sort of does look like an E too, huh? It's actually a Greek S. Number of terms first. First number is what you get when you put in 1. So we plug in 1, you get the first term. Plug in 60, you get the last term. So what's the number of terms? There are 60 terms altogether. And first term is 7.5. Last term is minus 22. I don't know what that is. Minus 14.5. Yeah. And then multiply that together for 300 and 120, 420, 435. There we go. We getting that answer, minus 435, which the answer key has for number 19? Makes sense? Feel like you can do this handout? Handout will be due. So fill in the ones we didn't do. When there are like 10 left we didn't do or something. 10 to 12 of them or something. And that'll be due on, and section 3.5 will both be due on Wednesday. We have one more handout to go, geometric, for Wednesday.